So in this problem, they give us a couple of things. They give us that the radius has 5 inches, and they give us something about the rate of change of the volume. So V prime is negative 5 pi square root of h. So for part A, they want us to show that the rate of change of h with respect to time is this formula here. So what you can do is you can take the original volume formula, and then we know the radius. It's 5, so 5 squared gives us 25. And so now if you take the volume depends on time, okay, because we said that it said in the word problem that h depends on time. So that means the volume is dependent on time as well. So if we take the derivative of the volume with respect to time, we get 25 pi, and that's going to be h prime, because when you take the derivative of h with respect to time, it's a function of time that we don't know or don't understand, so we can leave it as h prime. Again, this represents what we're looking for. This is the derivative of h with respect to t, because we took the derivative of the whole thing with respect to time. And we also know what the derivative of v is. They gave it to us. I don't know why I can't write that nicely, but if you divide by negative 5 pi, divide by, we want to divide by 25 pi, don't we? Because we're trying to get h prime by itself. When you do that, you get h prime by itself, which is the derivative of h with respect to time. Then when you simplify this fraction over here, you're going to get square root of h, negative square root of h over 5. Because the pi's cancel out, 5 over 25 makes 1 over 5, and then it's negative. So there, we've shown our work that the derivative of h, derivative of the height with respect to time, is negative square root of h over 5. So now they're asking us to find a function, h as a function of time. To do that, we just need to integrate both sides. But before we integrate, we need to know with respect to which variable. So you can bump that dt to the other side by multiplying both sides by dt. You're going to get dh equals negative square root of h over 5 dt. But again, if this is with respect to t over here, we don't want an h. So let's move that to the other side by multiplying by negative 1 over square root of h. Okay, so now we have with respect to each variable. So if you integrate both sides, that one's kind of tricky to think about with square root in the bottom sometimes. So if you think of that as negative h to the negative 1/2, that might help. And then over here, that's just a constant, so that integration is going to give us negative 1 over 5t. By integrating this guy over here on the left, the power has to increase by 1, so we know it's going to be a 1/2, or square root. But when that 1/2 comes down, we need to cancel out. So how about this for our antiderivative? But I dropped something here. It's an indefinite integral I'm taking of both sides, right? It's not from one side to the other. So they're all going to have some constant c. I dropped that on accident. So you need plus some other constant c over here. Because if you add or subtract constants, if they're different constants that we get from integration, it doesn't matter, because when you combine them, it's just going to be another arbitrary constant. So I forgot that extra little piece. It's going to be important in finishing this out, because now we can plug and find out what that constant c is, because it has to be a specific constant c so that it meets this condition, h equals 17, t equals 0. So we can plug in 17 in here. Remember, that's a square root if it's the 1/2 power. And t equals 0 here, plus that constant c that we need to find. This is obviously going to be 0, so the constant c that meets the conditions that they're looking for is negative 2 square roots of 17. So now that we have that constant c, let's back it up before we integrate it, okay? After we, let's back up after we integrated. We almost had h by itself, which was our goal. We wanted a function of h as a function of time. Okay, so to finish getting h by itself, divide a negative 2 from both sides. That's now going to be a positive 1 over 10t when you divide that by 2. That's going to be a positive square root of 17 here. Finish getting h by itself. Take this, square everything on both sides to get rid of the square root. So you got 1 over 10t plus square root of 17 being squared. That's the function of h that we were looking for. Sorry, a little quick note about my arithmetic up here. I multiplied both sides by a negative 1 over square root of h. That needs to be positive there. So that makes that a positive, that makes that a positive, that's a positive, and so this should actually be a negative there. I don't think I screwed anything else up. So there's our function for h. That's it for this part. Now part C, at what time t is a coffee pot empty? So we want to know when the height is 0, right? Because when we're all the way down to the end. So let's just go back in this function. Plug in a 0 in for the height. And then we have something to solve. This should be not too bad considering all the other stuff we have to do. So you got to multiply that parentheses by itself. Remember, there's no distributive property of exponents. You can't just move that squared on the inside of everything. You've got to do this. Okay, so multiply those two parentheses. When you do that, we get this ugly beast. You can multiply everything by 100 to give you t squared minus 20 square roots of 17 plus 17. Oh my gosh, I just realized something. Forget all that. Because right here, you have everything you need. What's it take to make this equal 0? You need to just find out a value for t that you can plug in to make that equal 0. So just don't even multiply that out. You got negative 1 over 10t plus square root of 17. We just want to find out what it takes to make this equal 0. So subtract that 17 from both sides. Multiply by 10, you get t equals negative 10 square roots of 17. Oops, no, that's positive. Because when you subtract, the square root of 17, subtract square root of 17. And then you're going to multiply by negative 10, so it's going to be a positive. Final answer here. Okay, I was doing a way longer-winded way. It would have been quadratic formula. That wouldn't have been good. If you can just find out what it takes inside this parentheses here to be 0, it doesn't matter if it's going to be squared. 0 squared is 0. So just set that parentheses aside, like I did over here, and solve this equation. Get t by itself. And you should get 10, remember, we scratched it out, 10 square roots of 17.